We are going to start now lecture 4 of chapter 6, class 10th mathematics, triangles. In this lecture we will talk about the ratios of the areas of two similar triangles. So the first theorem that we have is the ratio of the areas of two similar triangles is equal to the ratio of the square of their corresponding sides. So if two similar triangles these are given to us, we know that if AB, C and DEF these are similar, we are saying AB over DE that is equal to AC over DF that is equal to BC over EF. This thing we already know. Further, we also know that if the two triangles they are similar, then these altitudes we are talking about AL and DEM, these are also in the same ratio. Now whatever result is saying is that if these two triangles these are similar, then their areas, we are saying that area of the triangle ABC, the ratio to the area of the triangle DEF, it is equal to AB square over DE square, AC square over DF square equal to BC square over EF square. So to prove this, we have drawn the perpendiculars AL and DM on the side BC and EF respectively. Now if we write the area of both these triangles, we are saying area of triangle ABC over area of triangle DEF. We are saying the area of triangle ABC, it is 1 by 2 into BC into AL, and area of triangle DEF, that is equal to 1 by 2 into EF into DM. Now from this relation we are saying AL over DM that is equal to BC over EF. So in place of AL we can write it as BC, in place of DM we can write it as EF. This 1 by 2 get cancelled, so we get it is BC square over EF square, and that will be equal to AC square over DF square, and that will be equal to AB square over DE square, and this is what we have to prove. This result we are saying this is what we have to prove. Now next is, if the areas of two similar triangles are equal, then prove that the triangles are congruent. So two triangles they are given to us, and it is given that both these triangles these are similar to each other and their areas they are equal. So if the area of these triangles they are equal, it means the theorem that we have studied earlier, it is area of triangle ABC to the area of triangle DEF. We are talking about this ratio. The values we have, it is AB square over DE square, it is AC square over DF square, and that is equal to BC square over EF square. Now if the area of both these triangles these are given to be equal, it means these ratio these are equal to 1. So what we get is, from these relations we are saying, from the first equality we will get AB is equal to DE, from first and second we will get AC is equal to DF, from first and last we will get BC is equal to EF. So we are saying this AB length it is equal to DE, AC length this is equal to DF, and this BC length this is equal to EF. So it means by SSS congruency criteria we are saying both these triangles these will be similar to each other. Next we have is, prove that the ratio of the area of two similar triangles is equal to the ratio of square of their corresponding altitudes. So this result we have already seen when we are proving our theorem, that the ratio of the areas of the triangle it is equal to the square of their corresponding sides. So we are saying if two similar triangles are there, this ABC and DEF, these are similar triangles, then we have AB over DE that is equal to AL over DM, and for the areas we have area of triangle ABC over area of triangle DEF that is equal to AB square over DE square. So combining these two results we will get it is equal to AL square over DM square, and this is what we have to Now next is prove that the ratio of the area of two similar triangle is equal to the ratio of their corresponding medians. So in our previous lecture we have proved that if two triangles they are similar to each other, then BC over EF, that will be equal to AP over DQ. Now area of the triangle ABC over area of the triangle DEF, we are saying this value, this is also equal to AB over DE. All these values, these ratio, these are same. That is equal to, we are saying it is AB square over DE square. So combining these two results, we will get this is equal to AP square over DQ square. This is what we have to prove. Now next we have is prove that the ratio of the area of two similar triangle is equal to the ratio of the square corresponding angle bisector segments. So as we have proved the last two questions, in the last lecture we have proved the result that AB, if these two triangles these are similar to each other, then AB over DE, that will be equal to, we are talking about the angle bisector segments. So angle bisector segments means we are talking about it is AX and DY. Again for the two similar triangles, we have area of ABC over area of DEF, that is equal to AB square over DE square. AB over DE, we are saying that is equal to AX over DY. So combining these results, we will get this final answer as area of triangle ABC over area of triangle DEF, that is equal to AX square over DY square. From where we are getting this result is, this is from our previous lecture we are talking about. You can refer that lecture for this result, or you can see the proof over here. Now the next question we have, if the area of two similar triangles are in the ratio 25:64, find the ratio of their corresponding sides. So the ratio of the areas, this is given to us. Suppose we are saying the two triangles we are talking about, they are ABC and DEF. These are the two triangles we are talking about. So we have this is equal to AB over DE square, BC square over EF square, and AC square over DF square. So what we get is that this value we are saying, you can write it is 5/8 square. So we get 5/8 is equal to AB over DE, that is equal to BC over EF, and that is equal to AC over DF. These are the values that we have to calculate, that is the ratio of the corresponding sides. Next we have is, in the adjoining figure, S and T are points on the side PQ. This is side PQ and this is the side PR. We are saying this S and T, these are the points respectively on these two sides, and such that PT, this length PT, this is 2 centimeter, TR it is 4 centimeter, and ST is parallel to QR. Find the ratio of the areas of the triangle PST to PQR. So if these two sides these are parallel, it means this angle at S and Q these are equal, this angle at T and R these are equal. So both these triangles, triangle PST, that is similar to the triangle PQR. So if these two triangles these are similar, so ratio of their area of triangle PST to the area of triangle PQR, that will be equal to the ratio of their ratio of their side, that is PT square over PR square. So that will be equal to 2 square over 6 square. So that is equal to 1/9, and this is what we have to calculate in this question. Next is the area of two similar triangles ABC and PQR are 25 centimeter and 49 centimeter respectively. So two triangles that are given to us, they are similar triangles we are talking about. This is ABC, and second triangle we are saying it is PQR. The area of this triangle is given to be 25 centimeter square. Area of this triangle is given to be 49 centimeter square. If QR, we are talking about this side, QR is equal to 9.8 centimeter. This is 9.8 centimeter. We have to find the value of BC. So what we will have is that 25 over 49, that will be equal to BC square over 9.8 square. So the answer we will get on solving this, that will be, so on solving these values, we will get the value of BC, that will be 5 into 9.8 over 7, and this value comes out to be 7 centimeters. So this is what we have to calculate, that is the value of BC we have, it is 7 centimeters. Next we have is the area of two similar triangles are 81 centimeter square and 49 centimeter square. So these are the two similar triangles. Here it is ABC and DEF. The area of first triangle, it is 81 centimeter square. Area of the second, it is 49 centimeter square. If the altitude of the bigger triangle is 4.5 centimeter, this is the bigger triangle we are talking about, its altitude is 4.5 centimeter. We have to find the altitude of the smaller triangle. It means we have to find the altitude of this triangle. The result we have studied is that the ratio of the areas of these two triangles, 81:49, that is equal to square of the ratio of their altitude. Suppose this is AM, this is DN. So we are saying that is equal to DN square. This value is saying 9/7. So the value of DN we get, that will be equal to 4.5 into 7 over 9, that is equal to 3.5 centimeters. In this question we have written this is AL and DM are the altitudes. In this figure we have shown it like this, that is why this DM is over there. So what we can do to resolve this issue is, in place of this M we are writing L, this place of N we are writing M. So we are getting it is M over here and M over here. So both these calculations shown over here and calculation made over here, they will be same now. Next is the area of the two similar triangles are 121 centimeter square and 64 centimeter square. If the median of the first is 12.1, find the corresponding median of the other. Now we are saying the ratio of the areas, that is equal to the square of the medians. So median of first triangle is given to be 12.1 centimeter. Suppose the median of the second we are considering it is x. So what we get is x square, that is equal to 12.1 square. These values we are saying, when you solve these values, it is into 64 over 121. Now what is 64? It is 8 square and 121 is 11 square. So the value of x we get, it is 12.1 into 8 over 11. So the answer we will get, that is equal to 8.8 centimeters. This is shown over here, and the corresponding median is 8.8 centimeters. So we are using this theorem, that the ratio of the areas, that is equal to the square of the corresponding medians. Now next we have triangle ABC similar to triangle DEF, in which AX is the bisector of angle A and D is respectively this DY. So we are talking about two triangles. This is the triangle ABC and this is the triangle DEF. We are saying AX is the median bisector of the angle, and this DY, this is the bisector of this angle over here. And we are given that this AX, this length AX, we are saying it is 6.5 centimeter. This length DY we are saying This is 5.2 centimeter. We have to find the ratio of the areas of the two triangles. The formula we know, it is area of triangle ABC over area of triangle DEF, that will be equal to AX square over DY square. Value of AX is 6.5, value of DY is 5.2. We are getting this answer over here. So the answer we get, it is 25 by 60. Next is, in the given figure, the line segment XY, we are talking about this line segment XY, is parallel to the side AC. These two lines, these are given to be parallel. This triangle ABC is there, and it divides the triangle into two pair of equal areas. So we are saying that the area of this triangle and area of this region, we are saying they are equal. We have to prove that AX over AB, that is equal to 2 minus root 2 over 2. So first thing we are talking about is, if we look at these two triangles, these two lines, these are parallel to each other. So this angle at X and A, these angles at Y and C, these are equal. This angle at B is common. So what we get is that the triangle BYX, this is similar to the triangle BCA. It means area of the triangle ABC, ratio we are talking about, to the triangle XBY, that is equal to AB square over XB square. Now next, it is given that the area of triangle ABC, that is equal to area of triangle BYX plus area of triangle, this quadrilateral we are talking about, quadrilateral AXYC, and area of both these regions, area of this triangle and area of this quadrilateral, both these are equal. So we can write it is equal to 2 times the area of triangle BYX. So this relation gives us, this is equal to, this ratio we are talking about, this will be equal to 2. If we substitute in place of ABC, we are substituting the value 2 times area of BYX, we get that this ratio is equal to 2. So what we get is that AB square over XB square equal to 2. This gives us AB is equal to square root of XB. We are taking positive sign because we are talking about the lengths over here, so we are not interested in negative signs with square roots. So answer we are getting, it is AB is equal to root 2 times XB. Now the value of this XB we are talking about, this is XB, it is equal to root 2 AB minus XA. We are talking about this whole length AB, that is this length we are talking about XB, that is equal to AB minus XA. So what we get is that AB is equal to root 2 times AB minus root 2 times XA. So this gives us root 2 times XA is equal to root 2 times AB minus AB, that is equal to AB into root 2 minus 1. So the value we are saying over here, that at this ratio we are saying that AX over AB, that is root 2 minus root 2 over 2. This is value we are obtaining after rationalizing this expression. You can see the expression we are getting, it is AX over AB, that is equal to root 2 minus 1 over square root 2. When we rationalize this expression, we are multiplying and dividing it with square root 2, and the answer we are getting, it is 2 minus square root 2 over 2. Next we have is, in the given figure, triangle ABC. This triangle we are talking, this is ABC triangle we are saying, and the triangle DBC. These two triangles are on the same base BC. If AD, this is AD we are talking about, intersects BC at the point O, prove that area of triangle ABC over area of triangle ABC, that is ratio of these two triangles, that is equal to AO over DO. So to prove this, we have done the construction over here and we have drawn these perpendiculars AL and DM. This perpendicular we are saying this is AL and this perpendicular we are saying this is DM. These are the perpendiculars that we have drawn over here. Now in the triangle ALO, we are talking about this triangle over here, that is ALO, this triangle, and DMO, these two triangles. We have this angle over here, it is 90 degree, and this angle at O, these are vertically opposite angles. So both these triangles, these are similar to each other, and if these triangles these are similar to each other, what we get is that AL over DM, this is AL over DM, that is equal to AO, about this length is AO over OD. Now the formula for the area of these two triangles we are talking about, the ratio of the we have to calculate is area of triangle ABC to the area of triangle DBC. We are talking about the formula for both of this, it is half. For this triangle it is BC into AL. For second triangle it is half BC into DM. This BC, this gets cancelled because they are on the same base. This half gets cancelled and we are left with is AL over DM, and that value we are saying that is equal to AO over DO, and this is what we have to prove, that the area ratio of the areas of these two triangles, these are equal to AO over DO. Now next we have is ABCD is a trapezium. So ABCD is a trapezium means that two sides we are talking about, they are parallel to each other, and the parallel sides we are saying they are AB and DC. These are the two parallel sides, and AB is given to be 2 times DC. We are saying if this length is x, then this length is 2 times x. If the diagonals of the trapezium intersect at each other at point O, these are the diagonals of this trapezium, and they intersect each other at this point O, find the ratio of the area of the triangle AOB, we are talking about this triangle, to the ratio of the area of the triangle COD. We are talking about the ratios of these two triangles. Now as these two lines these are parallel to each other, so angle at A and C these are equal, angle at B and D they are equal, and these are the vertically opposite angles, angle at O are equal. So both these triangles these are similar to each other. We are talking about two triangles, one is AOB and second triangle we are talking about is DOC, and we have proved that both these triangles these are similar to each other. So we get that the area of triangle AOB divided by area of triangle DOC, that will be equal to AB square over CD square. Further it is given that this AB is equal to 2 times CD, so we are writing it is 2 times CD square over CD square. So the answer we will get it is 4 upon 1. So final answer we are getting is that area of triangle AOB over area of triangle COD, that is equal to 4:1. Next, in a trapezium ABCD, we are talking about the point O is the point of intersection of the diagonals A, B and these are the two diagonals AC and BD. This point O we are saying it is the point where these two diagonals they meet each other. AB is parallel to CD. It is given that AB, this length AB, that is equal to 2 times CD. Area of the triangle AOB, this triangle we are talking about, the area of the triangle AOB, area of this triangle is 84 centimeter square. We have to find the area of the triangle COD. Now from the previous result, as we have proved in the previous result, we are saying the angles over here, this angle at A and this angle at C, these are equal. This angle at B and D, these are equal. So both these triangles, they are similar to each other. So what we get is that the area of triangle AOB over area of triangle COD, that is equal to AB square over CD square, that is equal to 2 times CD square over CD square. So that is equal to 4:1. The area of triangle AOB is 84. So area of triangle COD, that will be equal to 84 by 4, that is equal to 21 centimeter square. Now in this next question, it is given that these points D, F, E, these are the midpoints of the sides A, B, C of the triangle. We have to find the ratio of the area of this triangle DEF to the ABC, triangle ABC. Now look at this parallelogram DFCE over here. Why I am saying it is a parallelogram? Because in this triangle ABC, we are saying D and F, these are the midpoints. It means these two lines, these are parallel to each other. Similarly, this D and E are the midpoints for the triangle ABC. So we are saying that this line DE and AC will be parallel to each other. So if we look at this figure over here, DFCE, we are saying this is a parallelogram. If this is a parallelogram, it means this angle at D and this angle at C, both these angles, these are equal. Similarly, if you are looking at DFEB, I am talking about this figure over here. In this figure, we are saying this side DB and this side FE, these are parallel. So this is also a parallelogram. So we get that this angle B and F, these are equal. Now we are talking about two triangles. One is the triangle ABC and second triangle we are talking about, it is the triangle DEF. What we have seen till now is that this angle at C, that is equal to angle at D. Then next thing we have is this angle at B, that is equal to angle at F. It means both these triangles, these are similar to each other. So area of the triangle DEF over area of the triangle ABC, that will be equal to DF square over BC square. Now if we again look at this figure over here, what we have is, we are saying these are the points A, B, C, these are D, E and F. This point F, this is the midpoint of this BC. It means if the length of this BC is X, then the length of this FC is X by 2. When we are talking about DECF, we have seen that this is a parallelogram. It means the length of this portion DE is also X by 2. Similarly, the length of this, we are saying, say AC is Y, then the length of this DF, we are saying this will be Y by 2. So what results we are talking about? We are saying the value of DF, we are saying these points we have mentioned correctly. This point is F, this point is E. So what we require is, we require the length DF. So the value of DF, it is X by 2 square, and we are talking about the length BC, it is X square. So the answer we are getting, it is X square by 4 into X square. These two X square gets cancelled and we are left with 1 by 4. So we are saying that the area of the ratio of the area of these two triangles, that is equal to 1 by 4. Next is prove that the area of the equilateral triangle described on one side of a square is equal to the half the area of equilateral triangle described on the one of the diagonals of that square. So we are saying square is given to us. We have drawn a triangle on one of the sides and we have drawn another triangle on its diagonal. This is the diagonal we are talking about. We have drawn this triangle on its diagonal. We have to prove that the ratio of these two areas, it is 1 by 2. Now to prove this, we are considering the two triangles. We are saying one triangle, it is BCE, and second we are talking about ACF. Both these triangles, these are given to be equilateral triangle. If these triangles are equilateral, it means the measure of their angles, it is 60 degree. If all the angles they are equal, it means both these triangles, that is triangle BCE, it is similar to the triangle ACF. Now we know that the ratio of the similar triangle, they are equivalent to the ratio of their corresponding side. So area of triangle BCE over area of triangle ACF, that is equal to BC square over AC square. Now this is equal to BC square over, what is the value of AC square? It is BC square plus AB square. It is a square. This figure ABCD is a square. It means both these values, these are equal. So I am talking about this denominator term, that is equal to 2 times a BC square. So what we get is that the area of the triangle BCE over area of the triangle ACF, this ratio is equal to 1 by 2, and this is what we have to prove. Next is prove that the area of an equilateral triangle described on a side of a right angled isosceles triangle. We are talking about a right angled isosceles triangle. This is ABC we are talking about. This is right angled at B, and this is isosceles triangle. It means we are saying if this side is x, then this side is also x. Then we have, now we are drawing two triangles. One triangle ADB, which we have drawn on one of its sides, equal these sides, and second triangle we are talking about this triangle AEC, that we have drawn on its hypotenuse. So to calculate, we are saying both these lengths, these are x. So the value of this hypotenuse will be square root of x square plus x square, that is equal to 2x square, that is equal to root 2x. This value we are saying this is equal to square root 2 of x. So we have drawn the equilateral triangle. So both these sides, these are x root 2, x root 2. These two sides, these are x and x. Now further we are saying, if we look at these two triangles, we have to show that the area of this triangle on the hypotenuse, that is equal to double the area of this second triangle. So if we look at both these triangles, what we have is the ratio of the side AD to AE, that is equal to x over x by root 2. So the answer we are getting, it is square root of 2. Similarly, if we are writing it is BD over AC, the answer we are writing it is x over x by root 2. So answer it is root 2. So by all these sides, these are in the same ratio. So by A axiom of similarity, we are saying both these triangles, these are similar to each other. So if both these triangles, these are similar to each other, so we can write area of triangle ABD over area of triangle CAE, that is equal to AB square over CA square, that is equal to x square over x root 2 whole square, and the answer we will get on simplifying this, it is 1 by 2. And this is what we have to prove, that area of the triangle ABD, this triangle we are talking about, this is equal to half the area of this larger triangle. Next we are saying if D is a point on the side AB of the triangle ABC such that the ratio of this AD is to BD, it is 3:2, and E is the point on BC such that these two lines, these are parallel to each other, find the ratio of these two triangles. So if these two lines are parallel, we are saying these angles, these are equal. So these two triangles, these are similar triangles. So we are saying area of the triangle ABC over area of the triangle DBE, that will be equal to AB square over DB square. The ratio of both these values AD is to DB is 3 is to 2. Suppose this value we are saying it is equal to K. So value of AD we have it is K. The value of AD we are saying it is 2K, 3K, and value of DB we have it is 2K. So the answer we will get it is this value we are saying AD it is 3K and the value of DB we are saying it is 2K. So AB is 5K square over DB is 2K square. So the answer we will get it is 25 by 4. So we are saying the ratios of the two areas that we have, it is 25 is to 4. Now the next question we have in the given figure, DE, this line we are talking about, DE is parallel to BC. These two lines, these are parallel to each other, and AD is to DB, this ratio, if this value is 5K, then this value is given to be 4K. Find the ratio of the areas of the two triangles DFE and BFC. We are talking about the area of the ratio of these two triangles we have to calculate. Now we are saying the area of this AB will be 9 centimeter. Now look at the triangle ADE and ABC. For these triangles, these two angles, these are equal. These two angles, these are equal. So it means that the two triangles ADE and ABC, both these triangles, these are similar. So from this what we get is that DE is to BC, that is equal to AD is to AB, that is equal to 5 is to 9. This whole length we are saying this is 9 times K. Now if we look at the triangle DEF and CFB, we are saying the angle at this F, both these angles, these are equal to each other. Then this angle at C, this will be equal to angle at this D. These angles, these are equal. So what we get is both these triangles, these are similar triangles. So area of the triangle DFE upon area of the triangle CFB, that will be equal to DE square over BC square, and this value comes out to be 5 by 9 whole square, that is equal to 25 by 81, and this is the ratio that we have to calculate, that is area of the triangle DEF to the ratio to the area of the triangle CFB, it is 25 is to 81.